In our previous video, we talked about moles and how a mole is equal to 6.02 times 10 to the 23rd whatever. The problem with that is when you're measuring something out in a chemistry lab, you can't measure things out in moles. When you measure things out, you measure the grams or the mass of that substance. And so what we need to do is we need to have some type of conversion to go from moles to the mass of something. And the way that you do that is you use something that is called the molar mass. The molar mass of a substance is equal to the number of grams in that substance in 1 mole. Okay? So, the way that you do that is you simply go to the periodic table. Okay, remember on the periodic table that, for example, carbon at 6, and then it says C, and then it says carbon, and then at the bottom it says 12.01, maybe 12.011. Okay, what that 12.01 means is that represents the molar mass of carbon, which means that you would write it as 12.01 grams in 1 mole, or just 12.0 grams per mole. Okay, and that means that if you have 6.02 times 10 to the 23rd particles of carbon, that it will have a mass of 12 grams. Okay, for example, zinc. Zinc has a molar mass of 65.4. Okay, and what that means is that 1 mole, or 6.02 times 10 to the 23rd atoms of zinc, if you could count them out and put them on a scale, they would have a mass of 65.4 grams. Okay, iodine, another one, has a molar mass. Look at iodine on the periodic table. And notice on all these I did round. I did go to just one number past the decimal point, which is perfectly fine. Okay, the molar mass of iodine, the element iodine, is 126.9. So again, what does that mean? It means that 126.9 grams of iodine atoms will add up to 6.02 times 10 to the 23rd iodine atoms. Now, what we can also do is we can take these molar masses of individual elements and add them up when we have multiple elements together. For example, let's look at water. Okay, the molar mass of water is the mass of hydrogen times 2, because there's 2 hydrogen atoms in water, plus the mass of oxygen. So see how I did that right here? I took the mass of hydrogen, which is 1, find it on the periodic table, multiplied it by 2 because there's 2 hydrogens, and then I added the mass of oxygen. So H2O all total has a molar mass of 18 grams per mole. Okay, here's a little bit more challenging one, the molar mass of glucose. Okay, glucose, what plants use for photosynthesis, what our body uses, has a mass of carbon, which has a mass of 12, and there's 6 of them. So we times by 6. Then we add the mass of hydrogen times its number of atoms, which in this case is 12. And then we add the mass of oxygen times its number of atoms, which is 6. And then we add all that up, and you get a molar mass of glucose of 180 grams per mole. Okay, the molar mass of C2H3O2-, if you remember from Unit 3, that is the chemical formula of acetate. So acetate has a molar mass of, again, carbon has a mass of 12, and there's 2 of them. Hydrogen has a mass of 1, and there's 3 of them right here. And oxygen has a mass of 16, and there's 2 of them. Notice that the negative charge on the ion does not have an impact on the molar mass. If you have a negative charge or a positive charge, that does not affect the mass of that particle. Okay, so 12 times 2 is 24, plus 3 is 27, 27 plus, and then 16 times 2 is 32. 27 plus 32 is 59 grams per mole. All right, one more here, and then we'll do some more examples. Okay, on aluminum sulfate, Al2SO43. The key thing here is notice that 3 outside the parentheses after the SO4 goes to the sulfur and it also goes to the oxygen. So what that means is since there's 3 SO4s, basically it's this. Here's 1 SO4, here's 2 SO4s, and here's 3 SO4s. How many sulfurs are there? Well, of course, 1, 2, 3. So in SO4-3 right here, there are 3 sulfur atoms. And then how many oxygen atoms are there? Well, there's 4 in each SO4. And then there's 3 SO4s. So, yep, that's 12 oxygens. So, for aluminum, aluminum has a mass of 27. Again, I'm looking up these masses on the periodic table. And there's 2 aluminum, so I multiply by 2. And then sulfur on the periodic table is 32.06. So notice I round that up to 32.1. And then there's those 3 sulfurs, so I multiplied that by 3 here. And then oxygen again, because there's 12 oxygens, multiply 16 times 12, and you get 342.3. All right, so at this point, what I would recommend that you do, go ahead and pause the video at this point and give these, at least a few of them, a try and make sure you know how to do this. I'm going to grab my periodic table here, and I'm going to start going through these here in just a second. So the first one, barium, is 137.3, sulfur is 32.1, and oxygen is 16 times 4. And yes, I need a calculator for this, just like you. 137.3 plus 32.1 plus 16 times 4 is 64 equals 233.4 grams per mole. Okay, make sure you put that on the end of each of those. Okay, on H2O2, I'm going to start moving a little bit quicker just to not waste your time. Just check your answers if you would. Should be right around 34.0 grams per mole. 27 plus 31 plus 64. 58 plus 64 is 122 grams per mole. And yeah, I know I'm moving quickly. Hopefully you've already done these and you're just verifying your work with mine. If your answers aren't the same as mine, kind of look and see if your answers, what you're doing differently. Okay, calcium nitrate, CaNO3 is 40.1 plus 28. Yes, I'm doing some of that math in my head. So that would equal 164.1 grams per mole. Ammonium borate would be 42 plus 12 plus boron is 10.8 plus 48. 54 plus 48 is 102. 102 plus 10 is 112.8 grams per mole. And guys, if I'm making a mistake, I love making mistakes because then you catch it and then you tell me and say, hey, Mr. Johnson, I think you made a mistake. And I say, ooh, awkward. Okay. Iron is 55.8 times 2, which will be 111.6. Plus carbon, 12 times 3 is 36. And then again, be careful here on these oxygens. Oxygen is 16, and there's 3 O3s. That doesn't make 6. That makes 9. 16 times 9 is 144. So plus 180, or 144 plus 36, this is 180, and 180 plus 111.6 is 291.6 grams per mole. Okay, and so those are the molar masses that we are going to use, that we'll learn about in our next lesson, when we convert between moles and grams. Okay, it's just like a telephone number, though. If this number is wrong at all, then your answer is going to be wrong. If you push one number wrong on a phone number, of course, it doesn't work. It doesn't go to the person that you think it's going to go to. So same thing here. Make sure that when you're using these molar masses, make sure you're looking at the periodic table. Make sure you're getting the correct mass for each of them. And then again, make sure that you distribute, especially these numbers outside the parentheses. Make sure you distribute them correctly, multiplying that number on the outside by the number of atoms on the inside.